Hey everybody, and welcome back. Today in this video, we're going to be looking at some important formulas that you will need as you're studying for your civil FE exam. We're going to be diving into some engineering economics formulas. So today we're going to be looking at time value of money. So that is a very complicated, statement to just determine what stuff is valued at in today's time, in future time, or like how will you have to pay things over, months or a certain period of time. So I'm going to dive right in. If you don't know where I'm at within this handbook, you're going to make sure that you need to make sure that you have the handbook first and foremost. And so once you download this handbook, the most up-to-date one, you want to go into your bookmarks, and then you just want to go into your appendix specifications and click it. And then you want to click civil, and it will bring you right into the section that I was in. So we'll be focusing specifically on time value of money. Let's dive right in. So to get in the area that we need to be in, we need to look at our bookmarks and we need to go to engineering economics. So it is a important section, pretty big section in the handbook. So we just want to click our engineering economics, and that brings us to the engineering economics section. Now, when we're looking at time value of money, there's a few important terms that we need to understand. The first one being present worth, P. That's what is denoted by P. Present worth. It just means what is the value of something now in today's time, the present worth. So what is the amount of money that you have currently right now? That's present worth. Okay. So that's denoted by P. So you're going to see this, there's this big, table, and it looks pretty complicated, but all we're doing is we are trying to go from one value to another value. So the first one I just mentioned was present worth. So that's one value, and we may want to get that into a future worth, or what it's worth 5 years from now. So what is that represented by? Well, it's F. So F is going to be your future worth. So it's not what it's worth now, it's what it is worth in the future. So if you buy a house now, what will it be worth in the future? You can really take a lot of this engineering economics stuff and apply it to your day-to-day life, whatever you're, deciding to purchase, whether it's a car or a house or just an investment. You can kind of see how it can be worth something today, but it can also be worth something in the future. All right. So we have future, we have present. What about A? All right. Let's see A in this table as well. All right. So A is a uniform amount per interest period. Okay. I just read out the definition. You're probably like, what does that mean? So A is just, I would say, the amount of periods that you would need to split your specific amount in. So you can have a uniform period, or it's the same amount of payments that you'll need to pay. So like, for example, A would be how many payments would it take for you to pay your mortgage over the 15 or 30 years that you took out on it. So it would be that monthly payment, right? That, say it's $1,000, right? Your A would be $1,000 for the next 15 years, right? It's that uniform, the same payment that it takes over, a period of time. So with A, it doesn't mean that it's only monthly. It can be the same period for a certain period. So it could be monthly, it could be quarterly, it could be semi-annually, which I believe is just 2 times a year, or it could be yearly, right, where A is in years. So You have to be careful with how we look at and view A, because it's not a specific period. Like, they will let you know what that period is in the question, but just know that A can be, a value that happens every quarter, it can be a value that happens every month, or it could be a value that happens every year, or a day. I mean, they can split it up into so many different ways. So, all right. So this chart, let me try to explain this chart in more clear terms now. So this chart allows you to take one time period. So let's say 2F. So you're trying to get to a future value, 2F, given a present value. So if I say, hey, I have this gold chain, right? And it's currently worth 10,000. And so I want you to determine what it will be worth in the future, right? You're trying to get to the future given the present, right? So we would use this row of items. And so some of this stuff we'll continue. What is this? What do we need to know this? Well, sometimes it's written out when we're doing our solutions, as in 2F given P. So that slash represents given. So 2F slash given P. And so the I is the percentage. So what is I? Well, I is just the interest rate here. That happens over that period of time. So your interest rate can be, maybe you have to pay, I think for houses right now, it's like 6 or 7% in interest. So if I'm trying to get to a future, trying to determine the future worth, given the present, I know that I'm going to have to take into account interest. I need to know that. And then I need to know the number of years, or the N for that. All right, so my interest rate is going to be compounded in some way. So if they say it's compounded in years, then I know my N needs to be in years. If it's compounded in quarters, my N probably needs to be in quarters for this to kind of make sense. Okay, and why is there a formula here? Well, this formula is what we can multiply our value by to get it to actually convert. So this is like our conversion factor. So you may have the present. So let's say the watch is $10,000, and we'll take our $10,000 and multiply it by this factor to get the future value. So this is how we read this chart. And so I'll just kind of walk you through what this looks like. All right. The 1 plus I should be in decimal form. It shouldn't be in percentage form. N is just a number. So that N should not be a negative value. It should be positive, right? Okay. So if we want to go to present given a future, so let's say I say your investment after you work for 10 or 15 years is going to be $1 million. How much do you need to put now for it to be worth that in the future? So with interest, this interest can help you, right? So you're trying to go to the present. We want to find what you need to do now for it to be worth that in the future. And so you can go 2P given F. Hopefully this making sense. And then remember the slash is given. So 2P given the slash F. Okay. I is your percentage. N is the number of a period. So N is the number of years. Now this one is 1 plus I. Remember, I is going to be in decimal form. And then N, we're putting a negative in front of it. But remember that N is a number, so it would be to the negative whatever. It just means that this is going to be really small. All right. So 2a given f is similar things. We're trying to get a uniform amount given a future value, right? And so this is a little bit more complicated, but it's just plug and chug, literally. Now, if we're on a question, and let me not jump ahead of myself, hopefully this is making sense. The only other term that I haven't gone through is G. So G is going to be your gradient. And so it just means how much it is increasing or decreasing. So a gradient example would be, let's say in year one, you make $100,000 a year. And then in year two, you make 110,000. And then in year three, you make 120,000. If you compare those numbers, you'll notice that you kept going up by $10,000 each year. And that is what your gradient is. It's that amount of increase. Now, gradients can work similarly if you're going down. Like if year one you made 130,000, then year two you made 120,000. It works the same way, but that gradient is going to be just the $10,000, right? So if you want to go to a present value given the change and increase or decrease given G, right? You can do that. It's very long equation, but you can do it. Now, I like to save people time. So an important thing here is to try to use some tables that will save you some time. So there are some tables that we can look at. We scroll through this engineering economics section, and we have our factor tables. So what is a factor table? Well, it will show you what those values would be given a specific interest rate. So if you have a 0.5 interest rate, this is the only way that you can use this particular table. If you have a 1% interest rate, then you can use this table, right? If you have a 1.5% interest rate, you can use this table. So we'll just start with a 4%. So notice that there isn't a 3% interest rate table. So if the problem has 3% in there, you are going to have to I think I got ahead of myself. Let's try this again. Use my bookmarks. Anytime you get lost, try to use your bookmarks. It'll pull you back in. Okay, so you're going to use one of these formulas depending on what you're going to and what you're given. All right. So you may have to actually plug in the numbers, but with these tables, you really can use them to your advantage. So how do we use a table? Well, we need to know first of all, what we're trying to get to. So remember, the slash means given. So if we're trying to go to P given F, then we use this column here. If we're trying to get let's say we're trying to get 2F given P, we would use this one, 2F given P, right? And so now the next thing we need to do is determine the number of our end value, right? So if this is over a 5-year period, then I know that I would use this value, right? Because my n is equal to 5, right? So if I'm trying to get to a future value given a present worth over 5 years, and this is the factor, I would multiply my present worth to be. So I know that if I have, for example, it makes sense, right? If you are given a present worth of, let's say, $10,000, and we want to know what it will be worth after 5 years with 4% interest, then I'm going to multiply my 10,000 by 1.2167. And if we do that, then we get a bigger number. And so that just means, right, that interest, that 4% interest, you have to take that into account, and your future, it does increase. The value of it does increase, right? So just something to take note of. And you can really calculate a lot of different things. Like if you have a bunch of credit card debt and you want to determine some things, you can use some of these factors to really see, okay, how is this impacting me? If I have this interest rate over the next 5 years and I don't pay it down, what does this look like for me? So this is real life stuff. I know this is engineering economics, but it's just finance. The finance overlaps a lot with this, especially when you're making decisions for different projects. So yeah, this is how you use the table, and hopefully your numbers make sense. And yeah, if I know I haven't done too many examples in this particular video, but if you check out the guide and some further videos, you'll be able to get some real life examples of me going through some problems. So hopefully this was helpful. And if you had any questions, feel free to leave a comment. And that is all I have for you. So I will see you in the next one. Peace.